We're on topic 15, page 76, and we're going to break 76 into several parts. First of all, we're going to look at the definition of a rational expression, and we're going to look at the fundamental principles of fractions, various operations such as multiplication, division, addition, subtraction. We're going to go over all those things and show some examples. Like denominators, where we're doing addition and subtraction, unlike denominators, where we're doing addition and subtraction, concept of the least common denominator, and finally we'll look at complex fractions. So, definition of a rational expression. Here you can see it is a ratio, and that a ratio becomes rational, okay, such that the numerator p and q are polynomials, and we've done polynomials before. So an example of a rational expression would be x squared plus 5, the numerator, x plus 2, the denominator, and this is called a rational expression. It's the ratio of two polynomials. And if you want to go back to page 51, you can see what a polynomial is, and it's an expression in x that is a sum of terms that may be denoted in descending powers of x. So we did that before, and we talked about the degree and the coefficients, and you can go back to page 51 and review that if you think it's necessary. Now we're going to go over fundamental principles. They won't necessarily all involve rational expressions, but just to review what is meant, and when we get to the next video where we do examples on topic 15, we will use rational expressions. So here we have a PQ divided by QK, and where Q and K are not 0, because if Q and K were 0, the denominator would be 0. If you multiply Q times 0 or K times 0, you get 0, and 0 on the denominator means that the ratio would be undefined. So there is that proviso. This means does not equal. So you can see here the K cancels in multiplication. This means P times K and Q times K. We can cancel the K on the top and the bottom. So for example, if we have 4x times 4y, we can cancel the 4's and get x over y. If we have 2a over 14b, I can look for the greatest common factor. Here is 2 and 2, and then I get 2a over 7b, because 2 times 7 gives me 14. 2 times 2 gives me 4. So in this case, I can cancel the 2's both cases, and I'm left with 2a over 7b. Now, I always look at this expression when I finally get something, as I should have done over here, and see if I can reduce it anymore. Well, you see, there's no way, there's no number that goes into both 2 and 7, so I can't reduce that anymore. So always ask yourself at the end, can something be reduced? So here we have 4ab over 14b. We're going to take out 2b from the numerator and 2b from the denominator. You can see that 2b times 2a gives me 14ab. 2b times 7 gives me 14b. So now I cancel the 2b and the 2b, and I'm left with 2a over 7. Here I have 5xy squared over 15x squared yz squared. I can take out 5x from here, and I can take out 5x from here. And I take out the lower, if you look here I have x to the power 1, here I have x to the power 2. So I take out the lowest power of x right here. And here I have y squared and y to the power 1, so I take out the lower of those two. So that's why I take out the 5xy and the 5xy here. I don't take out a z term because there is no z term on the numerator. So I take out the 5xy times y gives me 5xy squared. 5xy times xz squared gives me 15x squared yz squared. I cancel the 5xy on the top and the bottom, and I get y over x z squared. And I ask myself, can I reduce this further? Is there some common factor to both the numerator and the denominator? The answer is no. So let's look at some simple operations. These won't all, as I said, involve polynomials, but just a review before we go to the next lecture where we will use polynomials. But these are just using some very simple arithmetic examples. So if I have 2y, 2 over 5 times y over x, I just multiply the 2 times the y, I get 2y. And 5 times the x gives me 5x. So this term on the left can simplify to this on the right. And you can see here p times r, multiplying the two numerator terms, and then we multiply the two denominator terms. Now remember, the denominator, these terms can't be 0, otherwise the fraction is undefined, the ratio is undefined. Here we have a times y, so we get ay. X times b equals bx. Usually, most cases, we put these terms alphabetically. That's why I reversed the b and the x, but I could have written xb right here. It would be exactly the same. Now, for division, we've got P over Q divided by R over S. And what we do is leave the PQ the same, and instead of dividing, we're going to change the division to a multiplication, and we invert or flip this. So the R goes from the numerator to the denominator. This goes from the denominator to the numerator. And I get PS, this. So I switch the division to multiplication, flip the fraction from right here so that this goes up and this goes down, and then I have PS over QR. So 2/5 divided by y over x is 2/5 multiplied by x over y. I flip this, or took the reciprocal, or inverted, and now I have 2x over 5y. Here I have ax divided by y over b, so this becomes a over x. I keep the first one the same, and I invert this one, and this goes up, and this goes down, and I get a b over x. Y. Now we're going to do addition and subtraction. Let's say we have, this means plus or minus. So if I have P over Q plus or minus R over Q, I'm going to get the denominators are the same here. So I can just add or subtract whichever is required, the numerator. The denominators are the same, so it's like denominators. So I've had 3a plus 5b, and both of them over x. I can just write this as 3a plus 5b over x. So I've got that common denominator, and the denominators are alike. Here I've got b, so I can add, or I can just say 3x minus 5y over b. But that's the simplest part, where the denominators are the same. What if the denominators are not the same? So if we've got an unlike denominator, let's say we have 3x minus 5y. This is 4 over 6. I can choose the least common denominator, 4 and 6. So that's what we do, the LCD. And that is 12, which is the smallest number that both 4 and 6 will go into. So I now rewrite the problem 3x minus 5y, 4 over 6. I put the common denominator right here. So the lowest number that both 4 and 6 will go into is 12. So now what I do is I say 4 into 12. 12 divided by 4. 12 divided by 4 gives me 3. And that's that 3 here. I put that up here. 12 divided by 6 is 2. That 2 goes over here. This term stays here, and this term stays there. I'll go over that again. We ask ourselves, what's the lowest number that 4 and 6 will both go into? And the number is 12. 12 divided by 4 will give me 3. 12 divided by 6 will give me 2. And so now I will have 9x minus 10y over 12. And I always ask myself again, can this be reduced further? Now, if, for example, you chose the wrong least common multiple. Let's say that you said that least common multiple was 24. The answer would come out to be 18x minus 20y, twice this and twice this over 24. So you could take out 2 from the top and 2 from the bottom and reduce it to that. So you wouldn't necessarily get a total wrong answer. You just have to realize that you'd have to reduce it further. So always look at your final answer and ask yourself whether you can redo it further. Now, the next way another way that you could do this, let's say you had difficult numbers and you couldn't see what the least common multiple was. So let's do it. Make the common denominator the multiple of each unique term in the existing denominator. So I'm going to make the least common multiple, or make the common denominator. I'm going to call it the common denominator. It's not the least common multiple. But let's say I don't know. Let's say I have 22 and 57. So I don't know what the least common denominator is. So what I do is here, I put both numbers. I take the common denominator of 4 and 6. Multiply each term in the numerator of the original equation by the denominator terms that are different from the one undergoing this multiplication. Okay, what does that mean exactly? So I got 4 and 6 here. I put 4 and 6 here. Since 4 appears down here, I'm going to multiply the top of this by 6. 6 appears down here. I'm going to multiply the top of this by the other one. That's all you have to do. Let me go over that again. You put the 4 and 6 in here. Since 4 appears here, you take the 6th term and multiply the numerator. Since the 6th term appears here, you take the 4 and multiply by the numerator over here. Okay, so then you then you do the arithmetic. 18x, 6 times 3x, minus 20y over 24. You can factor out a 2 from the top and the bottom because you need to reduce it further. And you get 9x minus 10y over 12. That's exactly what we got over here. So that gives you some idea of how to do that. 2 different ways to do this kind of problem. Now let's see, we've got another example here. We want to say 2x over 7 minus y over 6 plus 3y over 5 minus 5x over 6. We're going to look at method 1. Okay, we've rewritten it, and the lowest common denominator is 7 times 6 times 5 is 210. In other words, the lowest number that 7, 6, and 5 will all go into and give you an integer result is 210. Now, if you say, well, what about if I chose 42? 7 times 6, well, 5 won't go into 42. What if I choose 6 times 5? 30. Well, 7 won't go into 30. So 7 times 6 times 5 is the lowest common denominator, 210. Now you say, take the first one, 210 divided by 7 gives you 30. 210 divided by 6 gives you 35. And 210 divided by 5 gives you 42. Why do I need this? 7 into 210 gives me 30, so I'm going to multiply this term by 30. 6 goes into 210 35 times, so I'm going to multiply the numerator of this 35 times. 5 goes into 210 42 times, so I'm going to multiply 42 times 3y. And 6, as we've done it before, goes into 210 35, so I'm going to multiply the top of this by 35. So I get 60x minus 35y minus 126y right here. 42 gives me 126y, and minus 35 times 5x gives me minus 175x. So if I collect the like terms 60x and minus 175x, I get minus 115x. I collect the y terms minus 35y and minus 126y, I get 161y divided by 210. And as far as I can tell, this is cannot be reduced any further. There's no common term for this and this, and so no common number that will go into both of these. So now you say, well, you know, how am I supposed to know that 210 is the lowest common denominator? Well, that's a matter of trial and error and experience. But let's say you don't want to do it that way. Then the other way to do it is what is briefly, okay, put all individual numbers down. This is just what I said in the last example under method to the other. Put the unique number here. There's a 7 here, put it here. Put a 6 here and put a 5 here. I don't put this 6 again because it's already here. So I put the 3 numbers that are unique here, 7, 6, and 5. Now, since 7 appears here, I'm going to multiply the top of this by 6 and 5. 6 appears here, I'm going to multiply the top of this by 7 and 5. 5 appears here, I'm going to multiply the top of this by 7 and 6. And the same here, 6 appears here, so I'm going to multiply the top of that by 7 and 5. So here you see 7. If I take this, I take 7 times 6 times 5 and divide by 7, I get 6 times 5. If I take 7 times 6 times 5 and I divide by 6, I'm going to get 7 times 5. So that's how to do it. Basically, I just put the 3 numbers down, and then I say, okay, here there's a 7, so I'm going to multiply the top of this by the other 2 numbers. Here a 6 appears, so I'm going to multiply by the 7 and the 5, not by the number that appears here. Here I've got a 5, I'm going to multiply this by 7 times 5, and I'm going to multiply this by I'm going to multiply, if I divide this by 6, this should be 7 times 5. I'm sorry, over here, this should have been multiplied by 7 times 6. That's why I got, started to hesitate here. Anyway, you can just check it over, make sure it's right, make sure you've done everything right. And then here you've got 60x, 6 times 5 is 30, times 2x is 60x. 7 times 5 times y is minus 35y. 7 times 6 is 42, times 3 is 126, so I minus 126y. And here I have 7 times 5 times 5 give me minus 175x. The 7 times 6 times 5 gives me 210. And when I take the 60x and the minus 175x becomes minus 115x, minus 35y, and the minus 126y becomes minus 161y over 210. So this is the same answer as obtained with method 1, so you can do it either way. If you're good at your math, you can realize what the lowest common multiple is. If you're not, and you're not very confident, then you can do it this way. Now, when you do it this way, you will often have to reduce, so you have to be careful here. That's why you should always check that whether something, when you get to the final answer, always ask yourself, can this be reduced? Can I take a 2 out? And you can reduce it twice. For example, you could take a 2 out of something from the top and the bottom and then realize it needs to be reduced again with another 2 or a 4. So always ask yourself at the end, can this be reduced further? Complex fractions. So here we've got a complex fraction, p over q divided by r over s. P over q is the numerator, r over s is the denominator. What you do is you change the division into a multiplication and flip this. You just invert it. So r over s becomes s over r. Now, so a over x divided by y over b is a over x divided by y over b. I've just rewritten this statement. This is the numerator. This is the denominator. The numerator divided by the denominator. Now we flip the y over b and it becomes b over y. It's called complex because you have a fraction here and you have a fraction here. So it's called a complex fraction. We invert the second term and then change from division to multiplication. So for example, just to give you an example, here's 2 over x divided by 3 over y divided by 7/5. That's what I did. Now what I do is I keep this the same and invert this and change it to a multiplication. 5 times 2x is 10x. 3y times 7 is 21y. I ask myself, can this be reduced further? Does a 2 or a 3 or a 4 go into this? And the answer is no. So here we have 2x over 3y divided by 7y over 5x. So 2x over 3y is the numerator divided by 7y over 5x, which is the denominator. So I change this division to a multiplication. The denominator becomes the numerator, and the numerator becomes the denominator. 2x times 5x is 10x squared. 3y times 7y becomes 21y squared. Always check your answer to see if it can be further reduced. Now, as I said, a lot of these examples don't involve rational expressions, but rational polynomials, but we're going to see this in the next video. So this completes our introduction to topic 15.